Hello students, in today's video we are going to work on finding the limits for more complicated functions. So let's get started. First we're going to have you graph these three functions on your graphing calculator and adjust your window to the following values. Hopefully you've paused your screen and you're just coming back to check your answers now. So let's take a look at that function using Desmos. So in Desmos you'll see that this is what the function looks like. And this actually relates to a very important theorem called the squeeze theorem or the sandwich theorem. What it does is if you take a look at this blue arc, or the graph for y equals x squared, and the green arc, y equals negative x squared, what it says is that you can squeeze a function between the two similar values, or two similar functions, to find the limit. So for this particular function, we're really looking at finding the limit for x squared sine of 1 divided by x. Now you'll notice that as this function approaches 0, it gets squeezed in between x squared and negative x squared, so the limit as x approaches 0 should be 0. And we'll talk about this a little bit more in class. Now, let's take a look at these properties. So here are several properties of limits. This would be a great time for you to copy these, but what I am going to ask you to look at, and we'll quickly go through each line, is it basically states that the normal operations apply to it. So if I have two functions, we'll look at the first row, f of x, and we're adding g of x. The limit of both of those functions is the same and or equivalent to the limit of each function separately, and then we add them up. So you'll see that on the left side, you'll see that we added the two functions, but on the right side of the equal sign, we separated them, and that's how we can find their limits. Second row, same idea, but we're subtracting them. Third row, same idea, but we're multiplying them. We can find the limit of each function separately and then multiply their limits together. Fourth row, just division. Fifth row, we're talking about multiplying a constant k to that function. So we can take a limit of a function and multiply by that constant that we pulled out. And the last row basically says is if we find the limit of some function raised to a power, we can find that limit and raise it to that power right after. So let's take a look at this function on the top row. It says evaluate f of x for the limit as x squared minus 1 as x approaches 2. So you'll notice if we simplify that if we substitute if we substitute 2 in there, we get 2 squared, which is 4 minus 1 is 3. So we found the limit there. Let's do the same thing for g of x. For g of x, if we substitute the 2 in for our x, we get a limit of 4. Now, using the formulas that we had before, if we take the limit of f of x, which we found was 3, and we take the limit of g of x, which is 4, we found the limit of both functions combined is 7. For the second row, we're taking the function for the first one minus the function of the second. We find the limit is negative 1. You'll notice in the third row we're multiplying. So the limit of f of x times the limit of g of x, that's 12. Next row, we have the limit for f of x is 3 divided by the limit of g of x. So that's our limit there. Now if we were to take, for this particular case, if we take 2 times f of x, we're really just saying 2 times the limit of f of x, which is 3, and that would be equal to 6. Next row, if we were to take the function f of x and raise it to the power of 2/3, we're essentially just taking that limit, which is 3, and we're raising it to the 2/3 power. So that basically gives us the cubed root of 9. Next example is a little bit more complicated, and it requires us to go over the squeeze theorem in depth or use L'Hopital's, which I haven't exactly exposed you to yet. So We have two options of approaching this. A, you can ask me about this at class and I will gladly go through the proof. Or B, you could just trust that anytime you have a function of sine of x, it's always going to be equal to what that value is on top divided by 1 on the denominator. So what I'm saying here is, because we have sine 2x divided by x, anytime we look at that limit as x approaches 0, it should really be the number next to the x divided by 1. So let's take a look at another example of that. If we have the same function, and this time we change it to sine of 3x divided by x, that function would just be, or the limit would be 3 divided by 1. So let's take that one step further and say if we have x divided by sine of 4x, because all we did here is take the reciprocal of the function itself, this would just read 1 divided by 4 as that limit. Now, given this example, example 6, the same rules would apply, and in this instance the limit would be 3. Last but not least is a slightly more spicy problem. So I'm going to do this on the equation editor, so I'm going to move that a little bit closer to the front. Now you'll remember our rules. We can find the limit for each function. So let's find our limit. Which of course is not being, which I can't find right now. So we're going to move on. This, we're going to write it a little bit differently. The limit as x approaches 0 for x squared. You'll notice the limit as x approaches 0 for x squared is 0. And the limit as x approaches 0 for sine of 1 divided by x is actually going to fluctuate a little bit. As x approaches 0, the value for sine gets to 0. And the limit as x squared approaches 0 is also going to be 0. So the function here is just, or the limit is actually just 0. One more try on this one. We're going to take each function and separate it in this instance because this is going to be a little bit different. So we notice that there's an x on the denominator. So we can split this up into two functions. First function is x divided by x plus sine of x divided by x. Now if you remember our rules, the x divided by x is going to be equal to 1. And the sine of x divided by x is also going to have a limit of 1. So in this instance, the limit as x approaches 0 should be equal to 2. So I hope that helps. If not, make sure you write whatever questions you have, and that way we can address it in class tomorrow. That's all for now. I'll see you guys next time.